Good evening. So today we are going to discuss about assignment 5 long short-term memory model. So this is a RNN our long short-term memory is a machine learning model that has been used in many of the predictions in modern day machine learning and artificial intelligence. So this would be using the memory, it would be looking back into backwards, and it would be storing some memory, and it would be like it uses RNN, like a recurrent neural network kind of things. So it's a neural network and it uses RNN model. So now you can see in this assignment, so the first instructions, we are going to import all the necessary libraries, like all the auxiliary libraries. And then we need to import all the Keras. So we are using LSTM inbuilt functions here in the Keras. Like in the TensorFlow, we have Keras, and then we have LSTM and dense layers, dense models in the in the Keras. The next we are going to in this assignment we are going to use a data set for the airline passengers data set. And so firstly we are going to import the data set, like we are going to download the data set from the GitHub, and then we are going to print the data set, and we need to visualize the subset of the data set. As the data set contains millions of data, we just taking the subset that is of size 40, and then we are going to plot it in a graph. So here is the code, and you can see. So this is the subset, and what are the months are in the subset. The next here we get everything. Mm. The next is we're going to, we just download the data set and allow load the data set and visualize the data set subset. So this is the data set, and we are going to visualize the subset. This is a subset data set, and this is the passenger count, and this is the date, and this is the what is the passenger number, passengers, how many passengers have been traveled. So no, so in this assignment we are going to mainly focus on passengers column. So we need to take a look at the passenger column in order to understand more about what is the shape of the what is the shape, and what is we are going to our prediction label, or label, or it's a Y label, or I think we can call it as passenger column. So here we're going to find the passenger count. So we are mostly interested in passenger column. So later on in the assignment, we are going to take a look at the passenger column, and we need to convert its type into float. And then uh, next we need to normalize the data, so we need to reshape it, and then we need to normalize the data. So after normalizing, normalize it using uh, a transform scalar dot fit dot transform of data set, min max scalar, and we have only range of 0 and 1. So maximum is 1 and minimum is 0, we can see. So after that we need to print the shape. You can see there are 144, that is it's one dimensional. So so here comes the actual prediction problem. So here we are going to predict the next day passengers using the previous day data. So today's passengers, we have the data of today's passenger, and we need to predict the next day passenger. So there is a 1 day difference between, one day it need to be looking back. It need to look back 1 day. So every time the model need to look back 1 day, and you need to perform it recurrently, and it need to mm, store the some of the information from the previous day in order to predict the next day. So the same thing happens. So here is the data. Here is the uh, in train the data set. So we need to use these functions, like in order to generate the data set. you need to use this function. So here this function generate data set. We need to give the data set and look back, or like look back is here it is 1 actually. So then, and in the range of data set and look back minus 1, so he will be getting x values and y values, and we need to append the x and y values to that. Next, here we will be using that function using in order to prepare our data set. In order to generate our data set, we are taking look back as 1, and we are creating the data set. After data set is created, we need to split that into training and testing using train test split function in the sklearn. So we have used that one, and we need to check the shapes of that. So the next thing is we need to build the LSTM models using this training data set, and using the data set that we have built up before. So here we are going to use two layers in this model, in this LSTM model. So first is one LSTM layer with 100 units, and the input shape is one, and also the look back is also one that we have already taken. And the second layer is a dense layer with one output. It will be giving only one output at the end. So then again we need to compile, and we need to train the data set. So first, LSTM model is a sequential model we are here using, and we need to add the data. We need to add the layer LSTM layer in build function LSTM from the uh, Keras library. So we'll be getting input shape, and we need to create dense layer with one output. So we need to, so here we can see the summary, and then we need to compile using optimizer ADAM, and mean square error loss function we are using here. So that's a famous these both are the basic optimizers and loss functions that used in many of them. So again here the activation functions are defaultly ReLU, and then we need to train the data set using training data set. We have given 10 epochs, 10, it will, we currently do it for 10 times, and the batch size is 1, and verbose is 2. So these are our assumptions, like we can take anything. Next, again the data set is already like trained, and then now we need to test the data set. Uh, like it's having any error or anything like that. So train we need to see the error for the training data set. Then again, using this code, we need to test the data set. Like we can test the data set. The error in the train data set is this much, and testing data set is this much. And now the we need to compare the prediction of the actual labels. So how training data set is already, we have already labels for the training data set, and we will be predicting the testing data set labels and comparing both. So as you can see, we have we using just a uh, like prediction function, and then we were going to plot the plot the data in a graph. Like you can see, um, the actual line and the actual fitted line and the actual prediction lines are perfect. And then for the testing data set is also a little bit the training data set is a little bit near, and the testing data set is a bit far. So now let's see the performance, what is the performance of the data set. So here actually this is the output, the final output, that what the predictions are using the dotted, and the ground truths, what is the actual labels are using uh, actual labels are given with star x. So you can see for the training data set it is a little bit they both collide each other, but for the testing data set it is a little bit far. So that's the performance. It's not too bad, it's a very good model. And this is our assignment regarding the long short term memory.